Let's discuss this 12th question next. The question says a point on the hypotenuse of a triangle is at a distance A and B from the sides of the triangle. Okay, from the sides of the triangle, this point is at a distance A and B. As you can clearly see, this is a point on the hypotenuse, let's say, and it is at some distance A and some distance B from here. Let's say this is the x-axis, this distance is, for example, let's say this is y-axis, this is A and B. This is similar to the coordinate plane, by the way. And we can solve this question using concepts of coordinate geometry as well. Okay, can we do that? Yes, this becomes x-axis, this becomes a y-axis. We'll have to involve the angles, by the way, right? Because these lengths are given and the length of the hypotenuse can be dealt with in terms of AB, and maybe with the help of this theta, I can work out with this theta, right? If this is theta, this angle is also theta, right? This is perpendicular, this is perpendicular, this is theta, this is also theta. What do we get? Let's say if this is A, this is B, then I can easily find this length. PA sin theta will be B, and this further PA will be equal to, PA sin theta will be B, or PA will be equal to B cosec theta. That's what I get. Okay, what about PB? PB cos theta is this, or PB is equal to A sec theta. That's what I get, right? Okay, and now I can write the length of hypotenuse easily, right? With the concept, some concepts which I have developed in coordinate geometry. I can write PA plus PB, that's the hypotenuse, AB is equal to PA plus PB, and this is equal to A sec theta plus B cosec theta. And now the thing that remains is simple differentiation in terms of theta and maybe get the value of theta. So derivative AB of with respect to theta, what is that? A times sec theta tan theta minus B cosec theta cot theta. This is what you have. So this is equal to what? This implies that d by d theta of this hypotenuse length AB is equal to what? Okay, let's see this. This is A sin theta upon cos square theta. Okay, and this is minus B sin theta upon cos square theta. Just a minute, this becomes cos theta upon sin square theta. And this tells me, if you take the LCM, this is sin square theta, cos square theta, this becomes A sin power 3 theta minus B cos power 3 theta. What we can do is, we can convert this in terms of tan, maybe dividing by A sin cube theta. We can divide by A sin cube theta, A cos cube theta, sorry, A and cos cube theta, and what I'll get is, divide numerator and denominator by this, or basically we multiply and divide by this. Yes, yes. So this will become tan cube theta minus B upon A, right? A cos cube theta is what we have done, right? This is what you have done in the numerator, and we multiply by A cos cube theta. What will remain is A and cos cube theta, and denominator will be sin square theta. This is cos cube theta upon cos square theta will be simply cos theta in the numerator. This is what you get. If you observe, I can easily equate this to 0 and get a value of tan theta, for which we'll get a critical point basically, yes, for theta. Otherwise, for cos theta and sin theta, if you think about the extremes, cos theta equal to 0, sin theta equal to 0, what you'll get is a very small triangle or a very big triangle. Basically, very small triangle in this way, or theta becomes 90 degree in the other way, and in this cases both the extremes are there. That is, the side lengths will be actually, what you'll observe is side lengths will be, can you observe that side lengths, the hypotenuse length, if theta becomes very, very small, this hypotenuse will be very, very long over here, right? If theta becomes very, very large, this hypotenuse will be very, very large again over here, right? This is what you'll get, since theta, the hypotenuse has to pass through these points. So those are two extremes which you are not dealing with. We're dealing with the middle one, and that gives me the minimum length of the hypotenuse. Therefore, AB minimum implies tan theta is equal to B upon A power 1 by 3. That's what I'm interested in, right? Tan theta equals to this, and if tan theta equals to this for AB minimum, the minimum length of AB will be equal to what? This is AB, we already know, this is A sec theta plus B cosec theta. Yes, A sec theta plus B cosec theta, and I can easily find the value of sec theta. What is sec theta equal to? Now sec theta is under root of 1 plus tan square theta, and under root of 1 plus tan square theta, what will that give me? Okay, let's multiply them. A times under root of 1 plus tan square theta. Or can we draw the diagram triangle and then maybe solve this? Yes, instead of applying the formula. Yes, we can do that as well. Let's draw the diagram triangle. If this is theta, then this is b power 1 by 3, this is a power 1 by 3, and this is theta over here. This is the hypotenuse, right? We can use that. And this will be a times that hypotenuse, maybe that small hypotenuse, let's call this h, upon sec theta will be equal to hypotenuse upon b base a power 1 by 3 plus b times h upon b power 1 by 3 is what you get. This is a power 2 by 3, h will come out common, a power 2 by 3 plus b power 2 by 3. What is this h actually? This h is nothing but a power 2 by 3 plus b power 2 by 3 under root. Okay. So under root of this whole thing and multiplied with this whole thing will be a power 2 by 3 plus b power 2 by 3 raised to power 3 by 2. And yes, this is what we wanted to prove, right? That's the complete proof of this question for you. That's the 12th question for us, right? That's the complete solution of this 12th question. Very interesting steps over here which you need to take care of. You could have moved in the direction of coordinate geometry as well, but still we would need that theta for minimizing the value of length of the hypotenuse, right? That's the complete solution for this question.